Hi guys. I don't know if you noticed in last video, but we're kind of taking everything that we've been learning so far, kind of wrapping it all into one math problem. I like to call these monster problems. So for today and tomorrow's videos, each video would contain one monster problem, one question that kind of covers really everything that we've learned so far in this chapter. Before we do that, I have to officially teach you the fundamental theorem of algebra. Don't worry, I actually already taught it to you. I just didn't call it the fundamental theorem of algebra. The fundamental theorem of algebra says if p of x is a polynomial with a degree that is greater than or equal to 1, then p of x equals 0 has exactly n roots, including multiple and complex roots. Guys, that just means you can look at the biggest exponent to see how many answers there are. I already taught you that. N is the degree, and the degree is determined by the largest exponent. We already learned this. We're just getting an official name for it. All right, let's move on to monster problem number 1. Okay, so in this problem, we're going to run through as many of the different things that we've learned as possible to make sure that we're getting a nice big review. The first thing I want to talk about, according to the fundamental theorem of algebra, is that this question should have 4 answers, since my largest exponent is x to the 4th. Now, normally, what we learned yesterday was that we were going to look at our constant to see what the possible answers are. But this question doesn't have a constant. It's missing, and it stops at 10x. So before I can list my possible answers, I am going to take out a GCF of the letter x so that I have a constant that I can look at. In this new version, my constant is 10. So my possible answers to this question, or I should say, my possible rational answers to this question are 1, 2, 5, and 10, and they might be positive and they might be negative. We don't know yet. All right, so now we grab our handy dandy calculator and we start checking. So we start with the number 1, we type it in. You can either type it into the original problem or you can type it into this new smaller problem that's inside the parentheses. If it works in the first one, it'll work in the second one too. So you can try it in either or. And when I type in 1, it works. So I have found my first of my 4 answers. My first answer is the number 1. Okay, to recap, I took out a GCF. By the way, when you take out a GCF of the letter x, that gives us an answer of 0. There's another answer. Then I listed all my possible answers and I plugged them in until I found one that worked, which means it gave me an answer of 0. And the first one worked. It was the number 1. So I now have 2 out of my 4 answers, 0 and 1. To find my next answer, I'm going to use 1 and synthetic division to make my numbers smaller, to get those exponents down. So we want to progressively get the exponents down smaller and smaller and smaller till we have found all of our answers. After doing synthetic division, I now have a trinomial, x squared plus 3x minus 10. If we're lucky, our trinomial will be factorable. And this is factorable. This turns into the parentheses x plus 5 and x minus 2. And so now I can find my 2 remaining answers, which are negative 5, because we're going to subtract it to the other side, and positive 2. My 4 answers to this problem are 0, 1, negative 5, and 2. To recap some of our very first lessons, like all the way back to the beginning, let's take a look at some vocab words. So again, this has a degree of 4 since the exponent, the largest exponent, was a number 4. There's a vocab word that goes with that. It's quartic. So this is also a quartic, and it's a polynomial since it has more than 4 terms. Quartic polynomial. This is review all the way back to like the very first video that I made. The roots or solutions or x-intercepts are negative 5, 0, 1, and 2. Remember, when we're solving for the roots, we are finding x-intercepts on a graph. Since this has an even degree, this graph is going to start high, it's going to squiggle around a little bit, and it's going to end high. Now, I don't know what the actual graph looks like, but I just kind of sketched something out with my mouse, and it looks like this. It's crazy. It's okay. Starts high, ends high, and it goes through all my x-intercepts. This is the end of our first monster problem.